Namaste everyone, my name is Srikanth. Welcome to my channel CADiMate, where we are giving life to the boring subjects using CAD technologies. So in today's problem, we are taking this problem which appeared in one of the OU question papers. We have a multiple disc clutch with 6 active friction surfaces. So N value is 6, small n value. The power transmitted, that is P, it's 220 kilowatts and it's running at 400 RPM. So capital N, we have to write it as 400 RPM. And the inner and outer radii of the friction surfaces, that is R2 and R1. R2 being the larger one, that's 120, and R1 being the smaller one, that is 90 mm. These are the radii. So we have to assume that there is uniform wear and the coefficient of friction, that's mu, that is 0.3. And we are asked to find the maximum axial intensity of the pressure. Right. So be careful over here. We have to find the maximum pressure that's acting between the discs. So if you remember, for uniform wear, pressure is not going to be constant. So pressure is not going to be constant. In fact, the product of radius and pressure, that's going to be constant in this case. Fine. And as R changes from minimum to maximum, pressure changes from maximum to minimum. Fine. And we have been asked to find the maximum intensity of that pressure according to this formula. Now, if you remember the derivation of uniform wear theory, if there is a disc like this, we have to assume a small area dA on which the pressure acting is P, and that P is varying according to the formula R into P is equal to constant. And we are supposed to find the total load that's acting on this, and the total load is going to be equal to integration of the force. The force acting on the small area is going to be pressure into the small area. So this is what we have to do in order to get the total load. So the radii are varying between R1 and R2. So pressure formula, we have to substitute pressure equal to K divided by R. So when you substitute, K will come out 1 by R into dA. So dA, if you see here, this area that we have here, it's a very thin plate, and the area of that can be written as 2 pi R into the thickness. So this R and R value will cancel out, and we get K into 2 pi will also come out. So inside what we have is just dr, and the limits are R1 to R2. So the formula will give us K into 2 pi R2 minus R1. So this is a formula for the total load. Now K value we know here it is R into P. So in order to find the K value, we should either know the radius and pressure at one of the places. Fine. So because here we have been asked to find the maximum pressure, we will have to take the pressure where it is maximum. The pressure will be maximum where radius will be minimum. So we'll have to take R1 into P max. That's the value of K which we have to take, and 2 pi R2 minus R1. So this gives us the formula for P max. So to solve such problems, we'll have to form a formula tree, and this formula tree we have to do it in the rough work. Fine. So just to draw a line, a vertical line over the right side, and in the rough work area you can do this formula tree. So as you can see from this equation, we have to find the maximum pressure, and the formula for maximum pressure will be W divided by R1 and 2 pi R2 minus R1. So this is the formula for P max. If you remember the formula directly, it's okay, or else if you know the derivation, you can get it from that. Now here if you see the total load, it's not given. Total load, it's not given. Pi value is constant, R1 is known, R2, R1, everything is known. So W is the one thing that we have to find over here. So you should try to remember a formula which has W in it. So the best one I can remember is T, the total torque value. So that is N times mu W into R mean. Fine. So this is the formula for the torque that is transmitted, where N is the number of friction surfaces that's given. So let's mark out whatever is given. So N is given, mu is given, W we have to find, and this W is what we have to substitute over here. And R mean. Let us see if we know the formula for all these. So torque formula, we have to get it from the power. Power is equal to torque into omega. So this is what we have to substitute over there. Then R mean, if you remember, for uniform wear, the value of R mean is average, R1 plus R2 by 2. So this is what is the formula. So these two we can use it. So here this will give us the torque formula. This we have to substitute over here, and you can see all of them are defined. So we can find W over here. So is there anything? Everything else, is it known or not? Is what we have to see. So power is known. Omega is not known here. All are known. So omega we need to find. How to find omega? For finding omega, we have the formula, simple formula. That is 2 pi n by 60. So at this point you can see we have connected this unknown data with the given values till we have come here, and this is what we need to solve it in the in opposite order when we are actually solving the problem. So this we have done in the rough work, and this is the direction in which we need to solve it. So let's find them one by one. Omega 2 pi n by 60. So 2 into pi into n value is 400 by 60. So we get 41.89. So 41.89. So this is the value of omega. Next we have to find the value of R mean. Let us see R1 plus R2 by 2. And we know both the radii, 120 plus 90 by 2. Let us see what we get. One not 5. The average value here is 105, and that's in mm. So if you convert this into meters, this is what we get. So we found the R mean value. Next we need to find the torque. Now torque formula, we have to use the power formula for this, and yes, so power, don't confuse this with the pressure. This is power. The power by omega is what we have to use. So you can see the power value is given, that is 20 kilowatts. So 20 into 10 power 3 watts divided by omega value we just now calculated, that's 41.89. So we need to calculate this. So 20 into 20,000 divided by 41.89. So that gives us 477.44. 477.44. So this torque value we get it in Newton meters. Now this torque value we need to substitute here to get W, the total load. So let's now find the total load here. The total load formula, according to this, what we get is the torque divided by number of surfaces and mu and R mean. Let's see what we have here. So torque we know it's 477.44. N value is 6. And mu is 0.3. R mean value, that's 0.015. 0.105. So calculate this. So we get 2526.14. 2526.14. And this is going to be in meters, newtons. Because this is a load, this is going to be in newtons. So now we have found this. So we need to substitute that over here to finally get what we need. That is the maximum pressure. The maximum pressure will be W divided by R1 into into 2 pi into R2 minus R1. Let me substitute all these values here. So it's going to be W, that's 2526.14 divided by, I put a bracket here, and I need to put in all these values. So R1 value, it's 0.12, and into 2 into pi into one more bracket we need, that's R2 is 0.12 minus 0.09, bracket close, one more bracket close, and enter. So this is the maximum pressure that's acting on 116, so 111679.9. So this is Newton per meter square, because everything else we have taken it in that unit. So you can just modify it slightly and write it in, kilo Pascal. So this value here is same as Pascal, and we are taking the dot 3 digits to the left, so it's going to be kilo Pascal. So this here is the answer that's asked in the question. So thank you for watching this video. Like the video if you really like it. Subscribe to the channel for further updates regarding like this. Thank you.